In this video, we're going to be talking about how we can use the law of sines to solve a triangle. Solving a triangle is a concept that we've not had to deal with before, but ultimately it just means finding the lengths of any sides that are not given or the measures of any angles that are not given. It's also typical that they're going to ask you to find everything that's missing. Once in a while, you'll be asked to only identify one of those, but ultimately solving it just means simply finding what's not known. So in a problem of these types, you're going to be given three measurements consisting of some sides or some angle measures. And with that, one of two possibilities happens. You either use the law of cosines or you use the law of sines. In this video, we're going to be talking about the possibilities under which the law of sines would be useful. In a separate video, we'll look at the way that the law of cosines is used. So with that in mind, let's look first of all at what the law of sines states, and that's what we have here. In any triangle ABC, and we see a triangle here, ABC, with opposite side A is opposite angle A, side B opposite angle B, and side C opposite angle C. Now remember, in that notation, the lowercase letters indicate side lengths, uppercase letters or capital letters indicate angle measures. So in the law of sines, it says that for any triangle in this format, that the sine of angle A divided by the length of the side opposite the angle A is equal to the sine of angle B divided by the length of its opposite side, which is also equal to the ratio of the sine of angle C to its opposite side. For the law of sines specifically, you're going to use the law of sines when given one of two possibilities. Now, notationally, this is going to look very familiar. It's something you would have used when you talk about congruent triangles. The law of sines gets used when you're given an angle-angle side relationship or when you're given an angle-side-angle relationship. Now, what that means is what we're going to be given consists of two angles and one side. We're going to, from that, determine the measure of the other angle and the measures of those other two unknown sides. In this video, we're going to look at an example of each of these, and you'll get to see how similar the processes are for solving triangles in that setup. So the first one we're going to be looking at, number one, we're going to solve each triangle. It is also typical on these for the answers to not be whole numbers or nice fractional answers. For that reason, we're going to be rounding to 2 decimal places in this example, but as is always the case, you should just check the directions for the problem you're working on to determine where you should round. So in number one, we want the measure of angle B to be 118 degrees. The measure of angle C is going to be 36 degrees. And the length of side C is 14 units. So let's give ourselves just kind of a sketch to look at here. We have an obtuse angle, angle B, that measures 118 degrees. Let's see, angle C has a measure of 36 degrees, and the side opposite angle C is 14 units long. And we can see in this case that this is an example of angle-angle side, where the side is not between the two angles. If it were in this position, side BC, that would be an angle-side-angle situation. So in this case, the first thing you notice is that we have two of the three angles given, and then we know that in any triangle, the sum of the measures of the interior angles has to be 180 degrees. So in this case, that's what we're going to start with. The measure of angle A must be 180 degrees minus 118 minus 36. And from that, we find the measure of angle A is 26 degrees. And that's the first of our three unknown pieces of information. Now, the other two things that we're missing are the side opposite angle A, which we refer to as a lowercase a, and we're missing the side opposite angle B, which we refer to as a lowercase b. And that's where your law of sines is going to come into play, which is what we see here. Whenever we use the law of sines, we're going to now substitute in any values that we know. So in this case, we know the measure of all three angles, which will help in our numerators. And as far as the side lengths are concerned, we know the length of segment C is this 14. So our law of sines then becomes the sine of angle A, which we said is 26 degrees, over the length of its opposite side, which is unknown, is equal to the sine of angle B, 118 degrees, divided by the length of its opposite side, also unknown, so we leave those as variables, which is equal to the sine of angle C, which in this case is 36 degrees, divided by its opposite side, which is 14. Okay, so what we actually have here is some ratios that form proportions. So for example, if we were to ignore this first ratio, we see a proportion in which we could cross multiply and divide to get the length of side B. Likewise, if we were to ignore that middle ratio, we have a proportion that we can use to find the length of side A, and that's ultimately how you're going to end up solving these. Remember, the sine of 26, the sine of 118, the sine of 36, etc., those all have decimal values. And ultimately, when we're multiplying, for example, here when I cross multiply 14 times the sine of 118, I'm just taking 14 times the decimal value that the sine of 118 degrees has. So that's what we're going to do here. We're going to solve for the value or the length of segment B first. So we know from this one, if we cross multiply 14 times the sine of 118 degrees would be equal to the cross product B times the sine of 36 degrees. Okay, now what we know about variables in equations where we have multiplication going on here, if I want to get B by itself, then I divide both sides by the other factor in that product, the sine of 36. And remember, ultimately what we're dividing by here is just that decimal version, whatever that happens to be. We just look at it in a nicer form here. All right, so what's going to happen there on the right is then it cancels, leaving us with simply B. Now let's consider what's going on the left side. Here we're taking 14 times whatever this decimal is, and we're going to divide it by whatever this decimal is. And that's where your calculator is going to come into play. So here we're going to take 14 times the sine of 118 and divide it by the sine of 36. And we're going to round to two decimal places. So we'd say the length of side B is approximately 21.03 units. And that's the second of our three missing pieces. Now to find the third, we need to find the length of side A. And as I mentioned before, we're going to do that by ignoring this middle ratio and using our cross products again. So here 14 times the sine of 26 degrees is equal to A times the sine of 36 degrees. There again, to get that side length by itself means to divide by that quantity. So here we divide by the sine of 36 degrees on both the left and the right. And we'll determine from that that the length of side A is whatever this quotient results in. So there we'd have 14 times the sine of 26 divided by the sine of 36. And then we get a value of 10.44 for the length of that segment A. Okay, so we've finished our example, in this case of angle, angle, side. Let's look at an example of angle, side, angle next. Get the paper to come apart. Okay, so in this problem, we're going to be letting the measure of angle A be 18 degrees. The measure of angle B is 53 degrees. And the length of side C is going to be 10 units. And as I mentioned on the last one, the first thing that we'll want to do is go ahead and sketch that so we get a visual as to which law to use. All right, so I have a triangle A, B, C. A is 18 degrees. Remember that it doesn't matter if your sketch perfectly matches the numbers you're given. Now here we can see an angle-side-angle relationship. We have two angles. with the included side given, angle side angle still falls within that use of the law of sines. Okay, so as we started the last one, we'll start this one the same way. Given two angle measurements, start by finding the third. So the measure of angle C in this case is going to be 180 degrees minus 18 degrees minus 53 degrees, which tells us the measure of angle C is 109 degrees. Now it's very clear here that my diagram does not match the measurements that I'm given in the problem. But this is just a sketch to visualize the relationship. So don't get hung up on the fact that the sketch doesn't necessarily match the numbers themselves. Once we have that third angle, now we're ready to set up your law of sines. So in this particular case, we don't know the length of side A, opposite angle A, and we don't know the length of side B, much like what we didn't know in the last one. Okay, so here let's set up our law of sines then. The sine of angle A, which is 18 degrees, over the length of its opposite side A, is equal to the sine of angle B, 53 degrees, over the length of its opposite side B. Both of those two side lengths are unknown, which is equal to the sine of angle C, 109 degrees, divided by the length of its opposite side, which we know to be 10. So here you can see that your process is very similar to what it was in the last time. If we ignore this first ratio, we can cross multiply and divide to get the length of side B, and if we ignore the middle ratio, we can cross multiply and divide to get the length of side A. So I'm going to kind of speed through this process just like we did in the last bit. Ignore the first ratio first. So 10 times the sine of 53 is equal to B times the sine of 109. All of those, of course, are in degrees. To get B by itself, we divide by the sine of 109 on both sides. And then we go to our calculator. By the way, I didn't mention it before, but if you're using a graphing calculator specifically, you'll want to make sure that you're in the correct mode, not in radian mode, since these are given in degrees. All right, so the length of side B in this case becomes 8.45. Now I'm going to ignore this middle ratio and deal with the others. So cross multiply 10 times the sine of 18 degrees is equal to A times the sine of 109. Divide both sides by that sine of 109. And then go to the calculator. So here A is going to be 10 times the sine of 18 divided by the sine of 109, which gives us a value of 3.27 when rounded to the nearest hundredth. So ultimately, that's how the law of sines works. You can see that the two processes are very similar, whether you're given angle side angle or angle angle side. Ultimately, you start by finding the length, or finding the measure of the third unknown angle, and then from that, use the law of sines to find the lengths of those unknown sides. In a separate video, we'll be looking at how we use the law of cosines to solve a triangle in which you're given 3 side lengths or 2 side lengths with an included angle.